All right, so that's the end of the mesopelagic zone. We're now going to look at the deep sea. So everything below 1,000 meters deep. Down in this area, this is the largest habitat on Earth. Okay? It is the largest habitat on Earth. If you think about it, 75% of our oceans, or 75% of our world is covered in oceans. Sorry, not 75, almost 72%. And then only 10% of the ocean is the coastal ocean, and the rest is the open ocean. And so, and below 1,000 meters in the open ocean is considered to be the deep sea. This is and makes up most of the Earth, okay, the surface of the Earth. So it is the largest habitat on Earth. It does contain about 75% of all of the liquid water on Earth. It's found in the deep sea. And down here, it is cold. It is dark. The water down here is about 35 degrees Fahrenheit or about 4 degrees Celsius. So that is very, very cold. That's almost freezing, right? That's like 3 degrees above freezing. So it's very, very, very cold. We could not survive in those temperatures. So if we tried to like go down there and like if we were able to and like swim around, we would die pretty quickly of hypothermia, right? Because it's super, super cold. If you ever jumped into like almost freezing water and like had that feeling, yeah, that's what these animals live in all the time. Okay, so that's super, super cold. And many of the animals that live here, I think pretty much all of them, are exothermic. So their body temperature is going to match the surrounding water temperature. So their body temperature is going to be that almost freezing temperature, which is crazy. Because they are ectothermic and their body temperature matches that surrounding temperature, their metabolic rate is going to be slower. Okay, so they're actually going to use energy less quickly because their metabolism will be slower because it's colder. So it's crazy that they can actually live in these conditions and match that body temperature to the surrounding water temperature. One of the ways that they're actually able to do that and not like die is they have antifreeze in their blood, in their bodies. So normally under those conditions, any sort of ectothermic animal, their bodies would start to freeze. Your cells in your body, if you stayed down there and matched your body temperature to that surrounding water temperature, your cells and stuff would start to freeze. So these guys actually have antifreeze in their blood that prevents their blood and their body from freezing. And then they have a slower metabolism. Crazy. Super, super cold. It is constantly dark. There is no light that makes it down to these depths. That means the animals that we pull up from here are not countershaded because there is no light to be countershaded against. The animals that we pull up from down here are going to be like black or like this weird off-white color or maybe gray. Okay, so they're not going to be countershaded. They're just going to be one solid color. Some deep sea animals do use bioluminescence, so they will flash and stuff in the dark, but that will be much more rare down here in the deep sea. So because it's much more rare, the animals that do use bioluminescence and like are flashing and stuff, they will have eyes to be able to see bioluminescence and be able to see. However, but all the other animals that aren't using bioluminescence, they tend to be blind because there's no light for them to see anyways, so why would they need to see? So when you pull up an animal from the deep sea, if you see, look at their eyes are going to be either like, they're pretty much going to be teeny, teeny, tiny little dots, okay, and they're not going to be able to see. So if they don't use bioluminescence, they're blind, but if they do use bioluminescence, they'll have small eyes that they can see the bioluminescence with. So they'll have small eyes or they're blind. And you can actually tell the difference between a mesopelagic fish and a deep sea fish by the size of their eyes. If you pulled up a mesopelagic fish, their eyes would be huge, right? Because they're trying to capture whatever little bit of light is left. Whereas deep sea, there's none, so their eyes will be small. Many of the adaptations that the animals that live down here have are going to be for the lack of food as well, because there's even less food down here in the deep sea than in the mesopelagic zone. And they say between 3 to 5% of the food from the epipelagic ever makes it down here to the deep sea regions. We're going to say 5%. Okay? We'll be optimistic, say 5%. So that is their food source. All of that, like detritus and stuff that's coming down in the form of marine snow, that's going to be their food source. The animals down here are not going to be making vertical migrations. So in the mesopelagic zone, we had migrating fish that could migrate up to the surface to find another food source. These guys, they can't. Right? If they're like 5,000 feet deep in the water, they cannot take and make that migration up to the surface to feed. The pressure differences would kill them. So they cannot do that. So animals in the deep sea stay down here all the time. They don't migrate up to the surface to feed. And because there's not as much food, there are not as many animals down here. The most common type of fish that you'll find down here are bristlemouths and lanternfish. Or sorry, not lanternfish, anglerfish. They are going to be smaller. However, they will be larger than the mesopelagic animals. It's kind of weird. You're kind of thinking like, okay, there's less food, but they tend to be larger than the mesopelagic animals. The mesopelagic animals were between 1 and 4 inches, right? And these deep sea fish tend to be about 20 inches, okay? So, which is bigger than 1 to 4 inches. So how, with less food, how do they grow larger? Well, here's our theory as to why that is. We think that these deep sea animals actually spend most of their energy at the beginning of their life into growing. So they do live for longer periods than animals in the mesopelagic zone because their metabolism is slower, so they will live for longer periods. So at the beginning of their life, they'll put their energy that they get into growing and growing larger, and then they will reproduce later in life. Okay? Whereas in the mesopelagic, because they don't live as long, they will not put as much energy into growing at the beginning of their life, and then they will put most of their energy into reproduction. So they stay smaller, but reproduce more. Deep sea creatures get a little bit bigger and reproduce later in life. So that's why we think they average larger sizes in the deep sea. So here's our little fishy from Nemo. Is this a mesopelagic fish or a deep sea fish? Why is it meso? The big eyes, yeah. So that's a mesopelagic fish. Got the big teeth and stuff. This also would never happen because these guys can't make it down to those depths, but we'll pretend it can for the sake of Nemo. So, mesopelagic fish, go. Okay. So the adaptations that these animals had to the lack of food are going to be pretty much the same as the non-migrating fish in the mesopelagic zone, but they're just going to be a little bit more pronounced. So they're going to be even more sluggish and sedentary, even more lazy.